Hey, 8th graders, this is Mr. Schultz here, and we're going to be taking a look at 10-2-3. So 10-2-3. And this is going to be a little bit more on substitution method and just kind of finding out some of those solutions here. So on this one it says making connections, systems, and multiple representations. In this chapter, you have practiced writing equations to represent situations. These situations often require you to solve a system of equations. So far, you can solve that using the equal values method or the substitution method. Today, you will also represent these situations on a graph and will more closely examine the solutions to two variable equations, which is pretty much what we've been used to. Two variable equations would just be something like this. That has got two variables. You've got your y and your x, so two variables. Let's see what's gone next. So here's our situation. This problem number 10-63. The gondola conductor charges $2 for each yodeler and $1 for a xylophone. It costs $40 for an entire club, including the xylophones, to ride the gondola. Two yodelers can share xylophones, so the number of yodelers on the gondola is twice the number of xylophones. How many yodelers and xylophones are on the gondola? Wow, this is just a ton of information here. So we're going to represent this with a system, and we're also going to solve that system and then take a look at it on a graph and see how does that solution fit in with the graph. So let's take a look at that. Okay, so let's take a look at this here. Now, I know that you could probably do this in your head and start to just kind of add stuff up and make it work, but just like with solving equations, if you do that kind of guess and check thing, that works for a time period, but then eventually the problems start to get bigger and they start to get more complicated, and that just makes it hard to do. So while the problems are a little bit smaller and a little bit easier, let's practice doing this, and then you'll be able to scale up with it as they get harder, because this method will continue to work. So it says this. So the gondola driver charges $2 for each of the yodeler, which I'll call a yodeler Y, and then he charges $1 for each of the xylophones. So I'll call that the xylophone. And in total, it costs $40 for the entire club. So just from that, I can say that if it costs $40, that it should be equal to each of my yodelers plus each of my people playing the xylophone. But that is just the number of people. That's not the cost. So the cost is $2 for a yodeler and $1 for a xylophone. So now this is all going to give me that. So for example, if I have 10 of the yodelers, then that'd be a cost of $20 out of my $40, which would tell me that I have 10 of the xylophones. But there's a second part to this, so let's keep going. So in this next part here, okay, so then in the next part, I'm saying that 2 of the yodelers can share a xylophone. So the number of yodelers is going to be twice as many of the number of xylophones. So if I've got one xylophone here, this is my fancy one here, then I've got 2 people that can play it, that tells me that there should be 2 of them for every one of the xylophone. Okay, so if 2 yodelers can share a xylophone, it feels like you want to write this. 2 yodelers is equal to 1 xylophone. But that's actually kind of the opposite of what you're trying to write here. Because here, if I have 1 yodeler, that would be Y, then I would have 2 of the xylophones. Well, that's actually the opposite. We're trying to have 2 of the yodelers and 1 of the xylophones. So I actually need to write this the opposite way. I need to write that 2 of my xylophones is equal to 1 of the yodelers, because 1 of the xylophones times by 2 will give me 2 of the yodelers. So that is a key distinction to make there. So now we have our equation. I've got what my y is equal to. So I can just take and I can substitute in my 2x in for my y right there. So writing this out, I've got that 40 is equal to 2 of my y. Well, my y, I'm going to replace that with 2x. I'm going to substitute in that 2x there. And then I've still got my 1x left over here. And now the whole magic of this is that I've got, again, I'm down to just one variable. So 2 times my 2x is 4x. Plus I've still got my 1x, so I've got a grand total of 5x is equal to 40. Divide by 5, I get that x will be equal to 8. So I've got 8 of my xylophones. And remember, there should be twice as many of the yodelers, so that tells me that y should be equal to 16. So there's my solution, 8, 16. And again, I've got twice as many of the yodelers as compared to the xylophones. If I go and I check this price, well, 8 times by 1 would be $8 there, and 16 times by 2 would be $32. 8 plus $32 equals 40. We know that this is the correct answer. We have done it all correctly. So our correct answer is that, but let's go and graph each of these original two equations. So y equals 2x. So on this here, if I'm graphing y equals 2x, this is a y here, well then that it just means I'm going to start at 0. That's like saying plus 0, and I'm going up 2 every time I'm going over 1. So I'm going up 2 every time I go over 1, up 2 every time I go over 1, and so on and so forth to complete this graph. And I'm going to skip ahead here. All right, so there's my y equals 2x graph. Then my other graph I have is this one. So the 40 is equal to 2y plus 1x. So this one here, so 40 is equal to 2y plus 1x. Now, this one isn't set up in my y equals mx plus b form, so I can either convert that. You could also make a table of values and just start plugging stuff in. When x is 0, what is y equal to? When x is 2, what is y equal to? And go from there. Let's see this in y equals mx plus b form. So to do that, I'm going to take off x, and I'm actually going to flip this equation around here too, and just put this side onto here just so that it looks more like how we're going to be used to it at the end here. Let's actually do a different color here too. So I'd have 2y plus 1x is equal to 40, and I'm just going to go through and solve it. So I'm going to take off x on both sides, be left with 2y is equal to negative x plus 40. And again, I'm just putting that x out front so that it matches my y equals mx plus b form. And then I'm just going to do my last step, which is to divide by 2. Make sure to do it on both pieces. So y is going to be equal to negative 1/2 x plus 20. So now I'm just going to go ahead and graph that. So I'm going to go up to my 20 point here. I'm going to graph that, and I'm going down a half. So I'm going down 1 every time I go over 2. So down 1 over 2. Down 1 over 2, and so on and so forth. And let's see where they cross here when we get there. Be right there. And you might notice here now, after we draw this line, that my point of intersection here is going to be right here. So that's at 16, which y is my yodelers. So I'm assuming this is going to be 8 then. If I go down to here, that is 8. So this solution on the graph is showing me the same solution that I found out algebraically. All these things shake hands. They all align. So this graph, so this is kind of giving you another tool. You could graph this and find out your solution. You could solve it algebraically. You could solve it using equal values. All kinds of different options here to solve it. We're trying to give you multiple tools. Now, graphing works great when it's nice and easy points like this, but when you get into decimals, graphing doesn't become quite as useful there. Okay, here's our last problem today, and it's just going to take a look at two different concepts that are easy to get confused. So intercepts and intersections. So intersection is what we found last time, where we said that it was 816, but intercepts are saying where does the line cross the x and y axis. So it depends on what you are looking for. Are you looking for the point that the two lines are the same, or are you looking for when one of the points is 0 at some place? So we're going to take a look at the question and see which one we are talking about. So a 5-gram candle on a birthday cake is lit. 2 minutes after it is lit, the candle weighs 4.2 grams. How long will it take the candle to burn? Well, thinking about this, if it's starting at 5 grams and 2 minutes it's down to 4.2 grams, it's saying how long will it take to burn? Well, I'm talking about when is the candle going to be gone? That is an intercept. An intercept. Because that's saying when is it going to reach 0? When is it going to get down to nothing? Next one. A local bowling alley charges you $4 to rent shoes and $3.50 for each game you play. Another alley charges you $7 to rent shoes and $2 for each game you play. How many games would you need to play in order for both alleys to be the same amount? Well, there I'm talking about two lines. One is starting at that $3.50 and is charging me $4 to rent shoes, so it's going to be something like that. And the other one is charging you $2, but charges you a steeper rate to rent shoes. So then I'm talking about when are they going to be the same? That is going to be an intersection. That is when are they the same. So the same is a good word there to help you find that. Let's take a look at our very last one, part C.